guys, my name is Brandon Dennis, and I'm going to be talking to you guys about a dash camera and their functionalities. So, why a dash camera, you may ask? I wanted to pick a small item that is in my everyday life, especially when I drive. It's always in my vehicle as an extra set of eyes, so I wanted to learn how a dash camera functions when it's on and in idle. Plus, I wanted to learn more about the accelerometer that detects movement and turns on the camera to record. The data I would be recording and collecting would be from the accelerometer mainly, since most of the time the cars are in idle, it's waiting for a response such as movement to the car or something hitting it. In theory, I would have the data collected every 1 to 2 seconds. That way, if something activates the accelerometer, it can be captured as data, plus the camera would have the video evidence as well. I wanted to touch on what types of dash cameras there are. The one on the left is about $30 and it's considered a basic dash camera. It has 1080p resolution and has loop recording, which means that it will constantly record and delete the old file on there. It also has an emergency lock, which if there's an impact, it will save the video in a different location on the SD card so it can't be deleted until accessed by computer. Next is the parking monitor, which if the car experiences movement, it'll record for about 5 minutes. It also comes with audio recording on most of them. On the right is what I consider a higher end dash camera. It goes, I believe, up to $160. This one is pretty neat. This one can rotate the camera from the front view of the car to the back view. So if you need to record in front of you and then say a car is behind you getting too close, you can switch it around real quick and record behind you. It also has Wi-Fi connectivity and a mobile app, so you can see it from your phone. Say you're inside the house and you hear something happening in your car, you can look through the phone, through the app, and see what's going on. It has a higher CPU and it has a higher temperature resistance, and it has a lot more storage compared to the one on the left. This one is compatible to a 128 gigabyte SD card. The one on the left more or less is going to be around 32 gigabytes. It's always better to have a bigger storage capacity just in case for whatever happens. Say you need to access video from 2 weeks ago, it's going to be on there since it's 128 gigabytes. The one on the left is probably 32 gigabytes, so it's only going to maybe last you about a week. That's from my experience. Since I own the one on the left, I use this one pretty often, and it only keeps maybe about a week's worth of driving. But I mean, still a week's pretty good, right, compared to everything else going on. So what's in a dash camera? Since I didn't have the time or the money to go buy a dash camera and open one up, there is a ton of videos out there, especially online on YouTube. So I went ahead and looked at one and took some screenshots. I'll have the reference at the end of the presentation just to show you guys. Right away you can see the components such as an LED on the left, which is the white and black screen. It also has a lot of buttons on the side, which is for programming your date and time, different functions of the camera internally. As the user, you can change the dates, the times, the format of the card, the resolution of the camera, different things, right? Then on the right side, still in the left picture on the right side, you can see the SD card import, and on the bottom of the left picture is the charging cable that you'll be receiving the power from your car battery, essentially. You can see the CPU right in the middle, and I believe that is an audio recording to the left. So on the right side here, when they flip it back over, you can see right away the battery bank is just kind of sitting there plugged in. That battery bank can last maybe anywhere between minimum of 4 hours to maybe a whole 24 hours at most before the battery itself just dies. But that's if there's active motion for it to record. To the left here, I don't know if you can see my cursor or not, but these components here is considered the accelerometer itself. It's going to be very small, and they're implemented in there onto the board itself. And it's also nickname given is the G-force sensor. On this slide, I want to show you guys my circuit transformation. So on the left side here is the proposed circuit diagram. I use this to transform it into a Tinkercad representation. So on the left side here, the picture, the battery bank does have a switch. I just use that to represent that if the car is going to be on, it's going to be using the car battery. But if the car is turned off and it's in idle, it's going to be using the battery bank. And so the red is representation of the power going in, and the black is the ground, the power going out. So, and the green lines, they're there to represent the signal, such as like the camera's memory, it's going to the SD card. I wanted to represent that. Since there is a connection and there is a little bit of voltage being used between them, but not a lot. So I just want to throw that in there as well. The proposed equation is down below that long line there. So you're going to have the minus car battery or the minus battery bank, depending on what it is, and plus the other components. Down below are the components and the watts that they use. It is very difficult to find what each component does in a dash camera, so I had to look up the components individually. So as you see down below, a typical car battery is going to be 24 watts, and I used a 9-volt battery in my dash camera as a representation, so that one's going to be about 18 watts. I looked up some of the cameras. They average anywhere between maybe 4 volts to maybe 10 volts, give or take. So I just used a generic one, and I was able to get 10 watts for that one. The accelerometer, also known as the G sensor throughout my presentation here, when it's in idle, it's going to use 5 watts, but when it's active, it's going to use just an extra 0.4 watts to make it 5.4. The same thing with audio recording. When it's in idle, it's going to be using 15 watts, and when it's on, it's going to be 24 watts. And the SD card doesn't use a lot of power, so from the research I found, it's only using 1 watt. This is my Tinkercad layout. Before I dive in and talk about it more, I just want to let you guys know that all the research I've done, it is very difficult to find any dash camera circuit layout. Now, if you try to research it right now, you're probably going to find the circuit layout for wiring a dash camera itself into the car. But to find the actual dash camera, the small little box, the layout of inside of it, that is the hard part to find. I've only come across one other resource that kind of shows in like little bubble form what it goes through, but that's the only thing I could find. I guess people don't really release that as much. But this is what I have come up with. It's the basic design of it. So this bottom left part here is going to represent the car, and since I was having trouble with the power supply and Arduino working together, I had to make this circuit itself as well, only switching between these two just to represent it. So let's go a little bit here. So since the dash camera has a camera and an SD card and an audio recording, Tinkercad doesn't really have a camera, so I went ahead and used a big light bulb here, and for the SD card I went ahead and used a small LED light to represent that. And for the audio recording, well, I used a buzzer, even though it's not recording, it's making noise, but you guys get what I'm saying. And for the top part here, this is going to represent the accelerometer, or known as the G-force. This one's a force sensor, and with a little bit of programming, we're able to make that work here. So let's start the simulation. So this is going to be your car. It's going to be constantly powering it when you're driving, and when you turn it on, your camera is going to turn on with your SD card powering it. There is an option on dash cameras that lets you turn on or off the audio recording, so I put an extra switch in here, so just to show that it does work. Here we go. Now when you turn off the car, it's going to go into idle, so let's turn it off here. So it's going to go over into your battery bank, and now it's still being powered on with your SD card. In theory, it's only supposed to turn on when the force sensor turns on when the car is in idle. But to show that it does work when it's being powered, here it is, along with the audio recording. So let's turn this off here, along with this circuit. Now let me show you. So when the car is in idle and it detects any movement, the accelerometer is going to turn on the circuit for the camera and for the LED to turn on. Not likely the audio recording will be, but I believe there is some dash cameras that will record anyway. Since the Arduino has a 5-volt power supply, to power the rest of the circuit here, was having a little bit of trouble, so I had to put an extra 9-volt battery in here just to help power this side of it. So let's turn on the circuit here. Make sure I have to switch back over. So it is being powered on right now, and to represent that the force sensor would turn it on, it's going to be making some noise just as a visual representation and an audio representation. So it'd be turning on. So if this is going on, it would be turning on the light with an LED, and like I said, some of them do turn on or off the audio. So this is the circuit layout for my Tinkercad, and I think I've covered everything for the Tinkercad, so let's move on. Lastly, I wanted to just cover a little bit on the accelerometer. So this is the accelerometer. I tried showing it to you guys earlier before on the video of the screenshots I took of that dash camera. So these are the components for it. It's very, very small. It can detect small movements such as, like, look at the Earth's gravity. It's only 1.5 Gs. For the motion of a car or a plane, it's going to use about 2 Gs roughly. For my project, since it is a moving car, it's going to be detecting movement while in idle plus impact. It's going to be using more than 5 Gs to record it. So this one on the left is an analog style. There's a digital and an analog. This one is an analog, and in the dash camera before, it is also an analog. That's how I was able to figure out the voltages for it. So when there's nothing going on, it's just sitting there, it's going to be using the 2.5 volts, and when it is being turned on, it's going to use around 2.7 volts as shown on the right side here. So lastly, these are going to be my citations for everything. If you ever want to look up any more of them, there is some Amazon citations in here too if you do want to go find them and buy them yourselves. Hopefully I was able to convince you guys of maybe getting one yourself. And thank you guys. Now I'm opening up for questions.